Question 12 comes in two parts. The first part wants us to find the derivative with respect to x of this expression y equals to e to the x times ln x. Well, that's straightforward enough. This is a product rule problem. So dy by dx equals to differentiate the first one, hold the second one constant, I get e to the x ln x, plus differentiate the second one, hold the first one constant, so e to the x 1 over x. So that was straightforward enough. Not much of a challenge there. The second part is a little bit harder because we're asked to show that this horrible statement is true. X times d squared y dx squared plus dy by dx minus 1 plus x times y is equal to 2e to the power of x. So this is a little bit more tricky. Well, what am I going to do? I notice first of all that here I've got a second derivative. So I know for sure that I need to differentiate at least one more time. So I'm going to do that. But first I've got this horrible 1 over x here. I want to get rid of that quotient so that I never have to use a quotient rule. I'm going to multiply everything through by x. So I get x dy by dx is equal to x e to the x ln x plus e to the x. So now I'm going to differentiate both sides with respect to x. Both sides with respect to x. Okay, what do I get? Alright, hold the first one constant, differentiate the second one. So this is an implicit differentiation here. So I hold the first one constant, x constant, differentiate dy dx, I get d squared y dx squared. Product rule, so plus, differentiate this one now, I get 1, so that becomes dy by dx. Equals 2. So now I need to use the product rule for the product of three terms. But that's easy enough because it's just the same way that we use the product rule for 2. Differentiate one, hold the other two constant, and then sum them up like that. So differentiating x, I get 1, hold the other two constant, e to the x ln x. Plus, differentiate e to the x, well, I get back e to the x, and then hold the other two constant, so there's x ln x there as well. Plus, hold these two constant, x e to the x, differentiate ln x. Why did I write that? Don't write it, Mark. You differentiate it, so I get 1 over x, and then at the end I also had this plus e to the x, so plus e to the x, which is its own derivative. So what are we going to do at this stage? Well, if we look closely, we can simplify this slightly. This x here and this one here are going to cancel out, and that means that these two are going to become 2e to the x, which is good. This is what we like to see. There's a bit of a correspondence going on between these two. What about all the rest of this stuff? Well, this part here also looks quite good because of this part here, right? So we're happy here. It's this mess here that we're not quite so sure about. But it turns out there is some stuff that we can do. Is this bright enough? Yeah, it's bright enough. If you look at this expression, e to the x ln x, where have we seen this before? Well, right up here. It turns out that was the expression that we started with. This is y, and it also appears here, so this is also y, but we've got this factor x out the front this time. So let's see what we can write. We can write this down as x d squared y dx squared plus dy by dx equals to y plus xy plus 2e to the x. Well, we're very close now. All I'm going to do is factorize this one and move it to the other side. So I get x d squared y by dx squared plus dy by dx minus 1 plus xy, which is this term, factorized and moved to the other side, equals to 2e to the x. And that's exactly what we're asked to show. So we put a QED, quod erat demonstrandum, what we set out to prove, and we close this off.